Hey, good evening everyone. So this is Ansh and today we are going to start with the next session on the process architecture. So in the last session we have already discussed about the process architecture part, about the user process and the server process. So today we are going in more deep about that. Uh, okay. So we have discussed about few points on server process in the previous sections. Server process. So we have understand that this process is being generated or be created once the instance get allocated and the user process establishes the connections. So remember this, whenever Oracle database create this server process, and this server process is very important to handle the request of user process. In the previous section only we have discussed that this server process only handles the user process which is connected to the instance. Once a user process is connected to the instance, the server process is responsible to work on it. Whatever the client is requesting, the fulfillment is the process of the server process. So that's why it is known as also dedicated server process, which is a default. But in some situations, when the application or Oracle database operates on the same computer, it is possible to combine the user process and the server process in a single process. But as of now, we are not going too deep on that. Just remember, whenever a user process is being initiated and it get connected to the instance, the server process is being created with the help of the Oracle database, and this server process is dedicatedly helps in handling the client request. Whatever user process is going to trigger, that will be fulfilled by the server process, and the server process is being created on behalf of each user process. If there is 3 user process, so 3 server process will be generated and dedicatedly and will work accordingly. So server process is being created on the behalf of each user process, or you can say as the applications. And the following task that can be performed by the server process is, you can say that number 1, the task which a server process can perform is to parse and run SQL statement. So the parsing of the SQL statements can be done by server process, and this can be only done with the help of application, through the application, because we have the application server. So application team will trigger some query, and once the connectivity is established, server process will be created, and the query which is triggered by application team will be passed, and the SQL statement will run accordingly with the help of server process. Second thing what it does, it will read necessary data block. It will read necessary data block from the data files which is in the disk into the shared database buffer cache of the SDA, and it will move it to the database buffer cache. Whatever the client requirement is, the fulfillment will be done by the server process. The third is, it returns result in such a way that the application can process the information. So this is the most important thing that server process does. Apart from that, apart from these informations, there are another background processes, BG processes, which has its own significance. Background process has its own significance. We have a number of background processes. You can look at it into the diagram. Here you can see that the user process is generated when a user or application is triggering a command, and once user process is being generated, the listener will take into effect. Listener will be in between, which establishes a connection with the database instance, and once listener is able to make a connectivity with the instance, server process will be generated and it will be connected with the database instance. Whatever the user process will ask, the server process will perform, because it is a dedicated server process and dedicatedly work on the basis of the client requirement. Apart from that, we have some major and important background process, what we call as a DBW and CKPT, LGWR, SMON, PMON, Repo. So we will discuss more in details about this. But before going forward, I want to ask that what is the need of this background process? Obviously, there are server process, listener process, and user process. Then why there is a need for background process? Yes. So the need of background process is to maximize the performance and accommodate many users, because multiple n number of users will be connected to the database instance, and to improve the performance, because no one faced any issues, no challenges will be faced by any of the users. So in return, we have configured a number of background processes, so that with the help of background processes, the performance will be maximized and will be productive in nature. So once an Oracle database instance started, the background process is also initiated among standalone servers or rack server. So even you are working in the single instance, they are same background process what is mentioned here. Even the rack also, you can use the same background process, but in the real application cluster there is 2 instance or 3 instance, so there is additional some background processes. But for the standalone, this many background processes are present. And if you're not aware how to check how many background processes are there and what are the informations about the background process, so you can use this view for checking $BG process. With the help of this view, you can use this one, select star from $BG process. If you use this view, you will be able to identify how many background processes are there. So some background processes are created automatically when the instance is started, whereas some other background processes are manually being started. So we will discuss each and every background process in more details now. So let's start with number 1 background process, what we call as an SMON, or let me erase this one. So number 1 is SMON, number 2 is PMON, this is a process monitor, then it's a DBWN and the CKPD and LGWR. These are the most important background processes, and it is mandatory that you will be getting these questions if you are 1 to 2 years of experience in this field, or if you are a freshers, so interviewer will generally ask you the questions about the background process. So let's start with the first process, what we call as a SMON. SMON is nothing, it's a system monitor. The full form of SMON is system monitor. Here what happens, this system monitor, which is a background process, it helps in the instance recovery. Whenever an instance crash, whenever an instance failure occurred, this background process will help in starting your database instance, start up your DB instance very effectively. And the background process which helps in starting this DB instance will be the SMON, what we call as a system monitor. This is the major and the most important scenario and the most important point that an interviewer should be asking you, and you should be answering to them, that whenever the DB instance is failed or something bad happens to the database instance or database instance failure, or where instance recovery is required, you should be knowing that SMON should be a background process which is responsible to starting the database or the database instance recovery to perform. SMON is the mandatory background process. Apart from that, SMON checks regularly to see what whether the process is needed or not. If other process can call SMON to detect if there is a need of any other process. Suppose if LGWR is working, CKPT, DBWN, if any process is required, any need, so SMON used to check it regularly, always monitors other process also, and manually it is automatically it does cleanup. It cleans unused temporary segment. Unused temporary segments. Now you are not aware with the segments, extents, data files. In the later upcoming session, you will be able to know what is the segments, extents, and data files and all that thing. But as of now, you should understand that which segments, if the space is not being used, that segments or that space will be cleaned up on the regular basis with the help of the SMON. So this is the background process which is responsible to perform all the cleanup activities, as well as to bring your instance back whenever instance recovery is required. This SMON process should be in effect. Moving forward with the next process, that is the process monitor, what we call as a PMON. So the PMON is the most important process. If a database instance is up and running condition, you can use this command ps-ef PMON to identify whether the database instance is up and running or not. If you want to kill the sessions, or you want to kill the sessions of the database, you can kill the process ID or the PMON also. But in the rare of the rarest cases, we used to perform whenever database is not going down. So it's not recommended by the Oracle, but to validate whether database is running or not, you can validate with using this command by triggering it in the OS prompt. So what it does, the main functionality, the main purpose of this PMON is that it performs process recovery. Whenever a user process triggers some command and it fails to get the output, or a user process generally fails, on that scenario, it helps in recovering that process. Suppose a user process is unable to trigger any command or it fails. This U1 is the user which fails automatically or it is not able to perform any task. So PMON comes into effect, comes into the picture, and it helps into recovering the failure of this U1. So it helps in recovery whatever failing happening for the U1 or user process failing. So for that, U1 comes into picture and will perform the recovery. And how can it perform the recovery? There are n number of used cases. Number one, it clean up the database buffer cache. Time to time it clean up DB buffer cache. This is the database buffer cache. So time to time, who cleans up? It's the responsibility of PMON who cleans up database buffer cache. I have already mentioned, with the help of the complex algorithm LRU and TC, this database buffer cache is managed on. So time to time, on the regular basis, PMON comes into picture and it cleans up the database buffer cache when user process is failed. Apart from that, it frees up some resources that are being used by the user process. If unnecessarily resources is being used, so what it does, PMON frees up some resources that are used by user process. Also, the main important thing what process monitor or PMON does, it monitors the sessions for idle session timeout. If some session is sitting idle, it idly kill that sessions to log out from the database. Time to time or periodically, PMON checks the status of the dispatcher or the server process and restart any that have stopped running, or in case of some failure it has stopped running. So PMON's time to time check it and start the processes. And also PMON also registers the informations about the instance and the dispatcher process with the network listener. Time to time it also updates, like SMON and PMON, which checks on the regular basis whatever requirement is needed by the other background process. SMON and PMON monitors regularly, periodically, if to detect whether any process requires some need to perform efficiently or not. So this is the two important background process which helps in improving the database performance, and time to time it manages and improve the performance. So this is about the system monitor and the process monitor. Moving forward with other background process, what we call as a database writer as well as log writer. Let me show you. So DBWN is the database writer, which is very important database process. And in this, what happens, whatever block or whatever buffer which is present under database buffer cache, if this block is being committed, if this block or this statement is being committed, it should be written to the disk to make the changes into effect. So whose responsibility is to write all the buffer, all the changes buffer, all the committed buffer to the to the disk? So it's the responsibility of DBWN. N is the number of process. It varies from 0 to 9. So it's the responsibility of DBWN who writes all the modified buffer, all the dirty buffer from memory to disk, and the disk will be data files. So the purpose of DBWN is to capture or to carry all the modified buffers from the memory, and it will write down to the disk. One more thing it does, it advances the checkpoint. When we will study about the checkpoint, then we will be able to know what is checkpoint. It always advances the checkpoint. So this is a very important process. And you can also say that, okay, what does this DBWN means? DBWN is nothing, this is database writer, and N denotes the number of process, and the max to max process a database writer can be configured up to is 20. And you can also use the parameter like db underscore writer underscore process. This, with the help of this parameter, you can set the n number of background process of DBWN. So DBWN process writes the dirty buffer to the disk under following conditions, and if the condition reaches more than suppose more buffer is present in database buffer cache, you have to increase the DBWN, you have to increase the number of process. So in the following conditions, you should increase the number of database writer. And how to increase it? It is the parameter which is present under initialization parameter file. You have to increase that parameter, db underscore writer underscore process. With the help of this, you can improve the performance or efficiency of a database. Apart from that, we have one more background process is called log writer, and the log writer is also very important, which we have already discussed in the later sections. What it does, all the redo entries which is residing under redo log buffer cache, it will be captured from the redo log buffer cache with the help of LGWR background process, and it is written to the redo log files, and these redo entries will be responsible for doing the database recovery. So always and remember that it will write all the redo log buffer entries or all the redo entries from the buffer to the disk. And it has the following situations when it usually writes down, that I will discuss in the later sections, but you should be knowing that it has some situations. It's not that okay, only whenever this buffer will get full, redo log buffer cache will get full, LGWR will write down, or if LGWR wants now, then it will write down. No, it's not the situation. There are certain situations when LGWR background process will write the dirty buffer, LGWR writes the committed transactions or uncommitted transactions, what we call as the redo entries, on a periodically basis to the disk. And the situation is whenever a user fires commit, LGWR will write all the redo entries to the disk from cache. Number 2, when the redo log buffer cache will get 1/3 full. If redo log buffer cache, this memory area will get 1/3 full, it will write LGWR will write all the redo entries to the disk. Apart from that, there are also one more section. In every 3 seconds it will write. Apart from that, if 1 MB full, if the redo log buffer cache will get 1 MB full, it will write all the redo entries to the redo log files. So these are the things when it writes. And one more thing you should understand, it writes before a DBWN process writes the modified buffer to the disk. Understand, whenever a user is firing some commit, for committing a data, suppose if you are updating a salary from 200 to 300 and you have fired commit, what happens? This updated value should be written in a data file, because this is the main repository where data is being stored. But here the earlier data is located, and if you fetch some user, other user will fetch the records, it will get the older data. To make the data into current state, what happens? We have to write all the modified buffer from memory to disk with the help of DBWN. But DBWN only and only write when the corresponding redo entries, that statement, will be written into the redo log file. Once the statement is written in the redo log file, then only it will ask for DBWN that okay, LGWR has written the corresponding information, the redo entries. Now you are good to proceed and carry that particular piece of information, that buffer, modified buffer, from the memory and write it down to the disk in the data file. After doing that, the data which is present under data file will be replaced with the current data. So this is what LGWR does. And at last we have one more background process which is very important, that is a checkpoint. and checkpoint can be asked in the interview also. The purpose of checkpoint is very simple. It records the checkpoint information. It records checkpoint information. That's it. It records the checkpoint information and updates number 1 in data file header and number 2 in control file. So the two purpose of this checkpoint background process is it records the checkpoint information updates, and it regularly writes down to the data file header all the information, all the checkpoint information. It will update to the data file header as well as the control file. That's it. These are the things, these are the specific tasks of the background process which is been happening at the backend. So we are done with the process architecture. We have much more to go in it, but in the later sections we will discuss more about all the features and additional features that is being available in this background process as well as memory architecture. But as of now, you should be knowing as a layman that okay, what is the functionality of SMON. You should be able to tell someone about SMON, PMON, DBW, and at least one single line. So we are done with memory architecture and process architecture. In the next session, we will start with the storage medium. Till then, thank you everyone. Bye bye. Take care.